Alright, so we are continuing in section 6, topic 8. This is page, why? This is page 134. And we're just going to do some more examples of graphing polynomials. You can't get too much practice on that. You can't. You just can't. So you just go home and watch this for entertainment value, and you might learn something. So what example am I on? 4. Alright, sketch the graph of the following polynomial. Today on your assignment, you're going to be graphing, and graphing. So if you still get confused by this, make sure you pay good attention. Negative 81 x to the 4th plus 16. Have to what? I do. I got to factor out a negative 1. Before I do that, though, let's talk about, before you change anything, let's talk about the end behavior. What's the end behavior going to be? Up and up. Even says it's either up, down, down, right? Either up, or down, down. If it's negative, it's going to be down and down. If it's positive, it'll be up and up. Remember, odd is going to be different directions. See this dance? I told you I was going to like it. But when it's even, it's either up, or down, down. So in this case, since it's even and negative, it's going to be down and down. And how many degrees do we have? 4 degrees. So 4 degrees means we'll have how many solutions? 4 solutions, real and imaginary. Well, if I have 4 solutions, that means my graph can cross the x-axis how many times? 4 times. But is it necessarily going to cross 4 times? No. What if some of those solutions are imaginary? Will it cross at an imaginary spot? No. Okay. But 4 degrees means 4 solutions, which means possibly intersect x-axis 4 times. If your graph intersects the x-axis more than that, something's not right. But it could be less. You could have multiplicity. You could have imaginary numbers. Okay? And it might not cross at all. So, to figure out where it crosses the x-axis, this is not a quadratic. If it was a quadratic, we could factor by grouping if possible, and then set each factor equal to 0. We could use a quadratic formula, or we could use divide and slide a factor. But it's 4 degrees, right? And is it one of those that's 4 degrees, 2 degrees, 0, where we can rewrite as a quadratic? No. So, you said we need to factor out that negative 1, right? Because your leading coefficient's negative. And whenever that happens, you got to factor that out. And is there a GCF? Not a GCF, so the only thing we're going to factor out is the negative 1. And instead of setting it equal to y, I'll set it equal to 0 because I want to know where it crosses the x-axis. So where it crosses the x-axis, y is equal to 0. So I'll factor out a negative 1. When I do so, I divide each term by negative 1, and what's left? 81x to the 4th minus 16. Do you notice anything about that we could factor? Difference of 2 squares. 81 is a perfect square, x to the 4th is a perfect square, 16 is a perfect square, and there's a minus sign. So this is a difference of 2 squares. Do we know how to factor that? Yeah. So remember that GCF, just bring it down. It's a factor to factor the difference of two squares, make two sets of parentheses, set it equal to 0. Remember, one is going to get a plus sign, one is going to get a minus sign. What is the square root of 81x to the 4th? 9x squared. What is the square root of 16? 4. So it's jumbled up a little bit. It's 9x squared plus 4 and 9x squared minus 4. 9x squared minus 4, can that be factored further? Yeah, it can. Isn't it a perfect square minus perfect square? Yeah. Can we factor 9x squared to the plus 4 further? No, that's not a difference of two squares because there's a plus sign. So if it was factorable, you would need to do the t-chart. And a times c is 36, b is 0. Are there two numbers you could multiply together to get positive 36 and add to get 0? No, so we can't factor that. But 9x squared minus 4, it's a difference of two squares. Now really when we're solving it, we don't have to factor that completely, but it's always a good idea to get that practice. So remember, one set of parentheses gets a plus, one gets a minus. What's going to be my first term in each set? 3x. And my second term? 2. So now those two terms are linear. The only way to factor a linear polynomial is if there's a GCF. Is there a GCF in 3x plus 2 or 3x minus 2? Nope. 9x squared plus 4, we already tried to factor that. We couldn't. When your GCF, you don't do anything with that as far as it's completely factored. Okay? So we factored, but have we solved? No. And we know we're in 4 solutions. Okay? Set each factor equal to 0. Can negative 1 equal 0? No. So it's a factor, but it is not a solution. Okay? 9x squared plus 4 equals 0. We're going to solve for x. So what should we do first? Subtract 4. So we have 9x squared equals negative 4. Divide by 9. X squared equals negative 4/9. Have I solved for x? No, what do? Square root. And remember, when you're taking the square root of both sides, you have to take the positive and negative square root of the side that has the constant. Do y'all notice anything about this? What's the square root of negative 4/9? It's what? It's imaginary. So we could, the answer is positive negative 2/3 I, but is that going to help us with our graph? No, this is a non-real solution. But that counts as two solutions, right? Positive 2/3 I is a solution, negative 2/3 I. Because I know it has 4 degrees, so there will be 4 solutions, imaginary and real. So that is 2 of our solutions. Negative 1 equals 0 is not a solution. And then we know these aren't squared, right? So we won't be taking the square root. We'll get one solution from 3x plus 2, and we'll get one solution from 3x minus 2. So it'll cross the graph in just those 2 places. So I'll set both of those equal to 0. and just solve for x. You may have questions on that? Also, I forgot to ask, what is our y-intercept? 16, or constant. And the original problem was 16, so that's another point we know on our graph, right? So once I know what my zeros are, or my solutions, or my roots, I go ahead and start the sketch of my graph. And one solution is at negative 0.67. So that's between 0 and negative 1. A little closer to the negative 1. Positive 2/3 or 0.67 is between 0 and positive 1. A little closer to positive 1. We know it's down and down, right? And we know the y-intercept is 16. Now there could be some like little changes of direction in there, especially because it's 4 degrees. It's not a quadratic. So if you wanted to find some other ordered pairs between negative 2/3 and 0 and 0 and positive 2/3, we could do that. But I'm pretty sure for the most part, this is just a rough sketch, that it's going to look like a quadratic. Even though, because a lot of times, quartic polynomials look like quadratics. Not all the times. Sometimes they're going to have more loops in there. But let me put it in the calculator to double check to see if there should have been any other changes in here. Ooh, you know what? We can do this on Desmos, and I think it'll actually show up on the recording. Oh, I'm in the way. So we had negative 81x raised to the 4th power plus 16. A little bit. Yeah, no, it looks like a parabola. There wasn't any other changes in there. So we have it crosses the x-axis at negative 0.667, positive 0.667, y-intercept is at 16, and behavior is down and down. Looks like what we thought it would look like, right? We're good. Anybody have a question on that? Alrighty then. Let's do another one. Page 135. Now for the assignment that I give you, you can't just look at your calculator and sketch the graph. I'm not going to accept that. You've got to show me your work. You have to prove to me how you found your zeros and all that stuff. I wanted to talk about some stuff. I forgot. Go back to the previous page. What is my domain? all real numbers. What's my range? Just 16? Is 16 the highest y value I'm going to have or the lowest? The highest. So 16 is the highest y value I have. I can't have a y value of 17, 18, 19, 20, right? So basically 16 and below. Okay? So I don't say 16 and below. I'll probably just say y is less than or equal to 16. How would I describe the end behavior on the left side as far as negative infinity to positive infinity? Into that one. No. How would I describe the left side? What is negative, or what is x approaching? So x is approaching negative infinity, not because it's pointing down, but because as your graph goes in this direction, your x values are getting smaller and smaller and smaller, right? So as x approaches negative infinity, what is y approaching? Negative infinity. On the right side, as x approaches positive infinity, y approaches negative infinity. Now, I think we already said this, but does this particular graph have a maximum or minimum? Yes. It has a maximum of what? 16. It's your y value. And I think we pretty much answered everything we could answer about that graph. So on your next test, when you have to graph, and it might not be multiple choice again, make sure you know how to graph and be able to answer all the questions. Okay? All right, now page 135. I have one more for you, and then I'll turn you loose. So you're describing, when your arrow, you have a left side and a right side, right? So when x is going in this direction, it's going to negative infinity because the numbers are getting smaller. When x is going in this direction, it's going to positive infinity because those numbers just keep getting larger, correct? Your y's, when they're going up, they're going to positive infinity, and when they're going down, they're going to negative infinity. Okay? Just because it's going down doesn't mean everything's negative. So when my graph is going down, don't think about the arrow pointing down. I think about if your graph was coming this way. So is it going on your x-axis? Are your x's going towards the negative infinity or the positive infinity? When your graph's going in this direction. Your x's are they're getting smaller, right? So x is approaching negative infinity. When your graph is going in this direction, or now it's kind of easier to look at it when it's straight down, all your y values are getting, I meant to put a negative down there, smaller. They're going to negative infinity. So x is approaching negative infinity and y is approaching, did y'all write negative? Yeah. I said it, I just didn't write it. X is negative infinity as well. So on your right side, when your graph is going in this direction, your arrow, because it's going down, so you want to say negative, but your x values are slowly increasing because they're going this way. So your x's are approaching positive infinity, and your y's are going down. Your y's are getting smaller and smaller and smaller. They're going to negative infinity. Okay? All right, page 135. Sketch a graph. We have f of x equals negative x cubed plus x squared plus 6x minus 6. What is our end behavior? Down and up. Memorizing that is going to help you with the graphing. You're going to have to do a whole lot less math, okay? How many degrees we have? 3 degrees means 3 solutions, real and imaginary, meaning our graph could cross, possibly intersect the x-axis how many times? 3 times. Okay, so how are we going to find where the graph's going to intersect the x-axis? We're going to factor it, right? Hopefully we can factor it. Is it a quadratic? Can we use a t-chart and Vines line? Is it a difference of squares? Sum of cubes? Difference of cubes? One of those where it's like 420 where you can rewrite it as a quadratic? What's up with this? What? Factor by grouping. When I have 4 terms and it's factorable, factor by grouping is what we're going to use. So remember, that is where you group your first 2 terms together, group your second 2 terms together, and you're going to factor out the GCF separately, okay? And remember, whatever the sign is in front of the group that you're working with, that's the sign you're going to use. Even if both terms don't have that sign, that's the sign you're going to use. Do you have a question? Yes. Because there's 4 terms, and that's the only way to factor it. Doesn't mean it's factorable, but if it is, that's the only method we have for 4 terms, okay? So what is the GCF of these first 2 terms, including the sign we're going to use? What sign? Negative. Whatever the leading sign is, that's what you use. So we'll factor out a negative x squared. What's negative x cubed divided by negative x squared? X. What's positive x squared divided by negative x squared? Negative 1. I'm so proud. Usually students just cancel them out and put nothing there. You have to have a placeholder. Are we okay with that? GCF of the second group. Positive 6. Factor out a positive 6. What's left? X minus 1. Is what's inside parentheses identical? Yes. If it is, then this method of factoring is going to work. We can use it. If it's not, you either made a mistake. If you didn't make a mistake and they're not identical, then it's not factorable using this method, okay? We'll have to figure out something else, which we don't know anything else at this time. So if it's not factorable, we can't do it, all right? So what you do when you get to this point, make 2 sets of parentheses. You've got 2 terms here. They have a common factor of x minus 1. So we're going to factor out an x minus 1. What's left on the outside? We'll group it together. Okay? Oh, this is set equal to 0. Now, if we were not solving, we would want to make sure we factored out that negative. Well, let's just go ahead and factor it out. Factor out a negative 1, not from x minus 1, but just from negative x squared plus 6. So we would be left with positive x squared minus 6. Is that a difference of 2 squares? No, because 6 isn't a perfect square, right? So could I factor it 2 numbers that multiply together to get negative 6 and add to get 0? Is that possible? No, so I can't factor anymore, right? But have I solved? No, and remember, I'm looking for 3 solutions. So is negative 1 going to give me a solution? Oh. Will x minus 1 give me a solution? Yep. Give me a solution of positive 1. And x squared minus 6 will give me 2 solutions. We'll have to see if they're real or imaginary. 2 solutions because there's 2 degrees. So when you add 6 to both sides, what do? But negative 1 is a factor, but it didn't give me a solution. Okay? So x squared equals 6, what do I do with that? Yep, and then I get x squared equals 6. Square root. What's the square root of x squared? X. And the square root of 6, I'm going to have to graph this, so I would want it on I would want a decimal form. So I'm going to go with 2.4. But hey, I only have 2 solutions, and 3 degrees means 3 solutions. What have I not done here? Somebody knows.
Oh, the plus or minus.
Plus or minus. When you take the square root, you have to take the positive and the negative square root. And that's why I keep pointing out that the number of degrees tells you how many solutions you have. Because if you pay attention to that, because kids often forget to take the positive and the negative square root. So if you go back and see how many solutions you have compared to how many that you're supposed to have, that's going to help you realize I forgot something somewhere, okay? Because I would have my graph only crossing the x-axis 2 times when it should be crossing 3 because I have 3 real solutions. Positive 1, positive 2.4, and negative 2.4. All right, so that's why it's really important that you double check that. So once I know my zeros, I can go ahead and start sketching my graph. My solutions are positive 1, positive 2.4, and negative 2.4. Be right back. And my end behavior we said was down and up. So the first word describes the left side. So down, go to the 0 to the furthest to the left. Make an arrow pointing down. The right side is pointing up. So go to the furthest to the right. Don't we also know our y-intercept? What is it? Negative 6, so that'll be a good point to plot. So I need to pick some more points. I need to know what's happening in between these points, okay? So between positive 1 and negative 2.6, I need to pick a value for x. I'm not going to pick 0 because I already know when x is 0, y is negative 6, right? So that would be silly to pick that. So maybe negative 1. I could also do negative 2. I could do negative 1.93 if I want to make it difficult. I would just probably go with negative 1. And again, you can plug this into standard form or the factored form. I'm going to plug it in to the factored form where we got when we factored the furthest most. You got to be careful though because you've got negatives. Right here we're going to be squaring that negative. So we have negative 1 open parentheses, negative 1 minus 1. In this parenthesis, I'll make a little bracket. Negative 1 quantity squared minus 6. And this negative 1 is important because I'm multiplying it by these parentheses. So not yet, though. I need to simplify inside the parentheses. I have negative 1 times. What's negative 1 minus 1? Negative 2. Over here, what is negative 1 quantity squared? Positive 1, because it means negative 1 times negative 1, right? So what's positive 1 minus 6? Negative 5. Now I can just multiply them all together. What's negative 1 times negative 2 times negative 5? Negative 10. When x is negative 1, y is negative 10. So I'll plot that point. So I know this point is going to come down, hit that, it'll go through the y-axis at negative 6 and come back to my next 0. So I know it's going to cross. Again, I don't know how high or how low it's going to go. That's why I'm going to use my table of values to choose another point. Okay? Now remember, this is positive 2.4. I don't have to go right in the middle. I told y'all it doesn't matter what you pick. It'll be easiest if I just choose the number 2. You know what I'm saying? You know what I'm saying? So that's what I'm going to do. Again, I'm going to substitute it into the factored form. Negative 1 times, open parentheses, 2 minus 1 times 2 squared minus 6. So that's negative 1 times 2 minus 1 is 1 times, what's 2 squared? 4, and 4 minus 6, negative 2. If I multiply all that together, what do I get? Positive 2. When x is 2, y is 2. We went from graphing quadratics to graphing that. Is crazy. What's my domain? All real numbers. What's my range? Okay. If this arrow was pointing up, that would be true. Y would be greater than or equal to negative 10. But this arrow is pointing down, so it's going to keep going down to infinity, right? So it's all real numbers. If your graph is if your ends are pointing up, or down, then your range is going to have a limit on it. But if one side's going up and one side's going down, you know what I mean, the range is also going to be all real numbers. Coolio? Now, maximum or minimum, we would call this a relative minimum because it's minimum, it goes all the way to negative infinity. So there's not a minimum, but we would call this a relative minimum, and we would call this a relative maximum, okay? Because the maximum value is positive infinity. So we call that a relative minimum, a relative maximum. Remember, oh, and here's also a relative maximum. A maximum just means that it changes directions. The y's are increasing, they stop and decrease. A minimum, y's decrease, they stop and increase. Coolio? How will I describe the left side of my graph? What is x approaching? Negative infinity. and y is approaching negative infinity. The right side, as x approaches positive infinity, y approaches positive infinity. Any questions on that? Use these notes to help you. There's no way I can graph every single problem you're going to come across. Hardest thing is remembering about that factoring. And remember yesterday, one of our problems was the sum of cubes or difference of cubes. And then when we factored that quadratic that was left, it had imaginary solutions. We had to use the quadratic formula to help us factor it because it was not, or to help us solve it because it was not factorable, okay? So we know a lot of information that we have to use to help us solve these. All right, good luck.
Thank you.
You're welcome. All right, I will end this video now. Hopefully it has been beneficial to you at home and give you some homework. Remember how to end it.